We will now have a look at what splay trees are and how they work. Splay trees have been introduced by Daniel Sleater and Robert Tarjan in 1985. And the idea behind them is very easy. It's just whenever we query a key, we want to rotate it to the root. And from the Algorithms and Data Structure course, you should already know how a rotation works, but let's recap. If we have the following situation somewhere in the binary search tree and we want to move x up by one level, then we can do a right rotation around x. That means that we flip the position of x and y, and we take this orange tree and hang it onto y. And now x is one level higher and y is one level lower. In the same way, we can also do a left rotation here around y to get from this situation to this one. And now we have an additional operation, which is the splay operation, that tells us we rotate some key to the root. And then a query works as follows. First we splay the key to the root, and then we return the root, which is now the key that we want. Well, let's have a look at an example. We have this very unbalanced tree, and in the beginning we want to query number 8. So we pick it and we rotate it upwards, step by step, until we have it at the root, and now we can return it. Next, let's take number 6. So we find it, we splay it upwards, and then we return it. Take number 5, we splay it to the root, and we return it. Take number 3, splay it upwards, return, and 2, splay it and return it. And now we have a bit of a problem, because now we're exactly back at the start. This is exactly the same tree as we had in the beginning, and we did a quadratic number of rotations. That means if we do this, we had n queries, we took quadratic time. That means we required even amortized linear time per query, which is way too much. So somehow this does not work. Instead, we need a bit more involved rotations. We need double rotations. Instead of just going from here to here and here to here, we want to move vertices up by 2 levels. So let's say we have the following situation. We have our key x here, its parent y, and that's parent z, and we want to move x up. So we want to get something that looks like this. How can we do that? We can first do a right rotation around y to switch these two, then we get this tree, and then we do our right rotation around x, we switch these two, and then we get that tree. And that's something that we call a right-right rotation around x. So we move x upwards by 2 with 2 right rotations. And the same way, we can also go from here to here by doing 2 left rotations, one on y and one on z, and then we have a left-left rotation on z. But there are 2 other ways that the tree could look like this one or like this. In both of them we want to rotate the y up, and we want to get here. To do that, we can move from this to this with a left rotation, and then here to here with a right rotation. So this is a left-right rotation around y to move y to the root of this subtree. And the same way, here we do a right rotation on y to get to this, then a left rotation, so this is a right-left. And symmetrically we can also define left-right here, right-left here, but these are the ones that we really need. We need a left rotation, a right rotation, left-left, right-right, left-right from here to there, and right-left from here to there. If we have this situation, this doesn't really matter to us, because we only look at a node and its 2 parents, and we don't have the situation here, so we don't have to look at all those outgoing errors. And now with these double rotations, we want to do it again. So let's have a look how the algorithm looks like. We have some node x, and we want to splay it. If x is already the root, then we're already done. So otherwise, we look at its parent. And if that parent is the root, then we cannot do a double rotation, then we have to do a single rotation. So we have to differ between 2 cases. Does it look like this? x is smaller than y, then we do a right rotation, or the other way around, we do a left rotation. If y is not the root, then we want to do a double rotation, so we again take the parent of y and define it as z. And now we have 4 cases. Either this one, x smaller y smaller z, then we do a right rotation, or this one, x greater y greater z, we do a left rotation to go up here, or one of these mixed one, for example y smaller x smaller z, then we do left right, or z smaller x smaller y, then we do a right left one. And these are the only cases that we can have. And after we're done with moving x by 1 or 2 levels upwards, then we just recursively call splay on x again until it is at the root. So let's have a look at an example. We have this tree and we want to splay number 3. So we find it, we look at its parent, and we see, oh, it's not the root, so we have to do a double rotation. We take that one's parent, and we have this situation. We have z, smaller x, smaller y, so we do a right-left rotation here, which changes our tree like that. Then we call splay again. And now the parent of x is the root, so we only do a single rotation, and x smaller y, so it's a right rotation, and we get this tree. We recursively call it again, but now we see x is the root, so we are done. So we want to use this function splay of x whenever we query or search for something. Whenever we insert a key, we also want to move it up to the root. And we also use it whenever we delete a key. So we move it to the root, remove it, and then we join the 2 trees that we get. For the deletion, it's not that important. There you can also use other methods like remove the rightmost key in the left subtree. But this is just up to choice for you. So these 2 are the more important ones. Whenever we search and insert, we always want to splay it to the top. And in the next part, we want to find out why this function is fast and how it helps us to achieve all those properties that we want to have.